Hey guys, welcome to the flight dynamic course. Today we are going to see the topic on aileron power. So aileron is the primary control surface of the airplane to control the roll or to avoid the roll. So here we are going to calculate the aileron power and the importance of aileron. The introduction of aileron power refer to the effectiveness and control authority of aileron in general roll movement. So it determines how quickly and forcefully an aircraft can roll to achieve a desired bank angle or to roll angle. The aileron power is influenced by a factor such as aileron size, location, placement, and deflection angle of the aileron. The higher aileron power results in better roll responsiveness, which enhancing the maneuverability of the airplane. Next, to understanding the aileron power is crucial for an aircraft designer and to control it to make optimal design or optimizing the controls. Next, the role of the aileron to control the roll. Ailerons are control surface locating on the leading edge of each wing of the airplane, primarily used to control the rolling moment. By deflecting its opposite direction, aileron can create lift difference between wing which causes the rolling moment. The roll controls allows the pilot to bank the airplane or the aircraft, which is essential for turning. Next, the effective roll control is critical for maintaining stability and extractive precise maneuver. And aileron power is directly affect the responsiveness and the efficiency of the rolling command. So in this figure, we can see the deflection of upward aileron and downward aileron, which aircraft to roll in a clockwise direction. Next, the factor which are affecting the power of aileron is one is aileron size. Next one is deflection angle of the aileron. Third one, the amount of weight or the wing loading. The next one is the air speed. Finally, the wing position also plays the effect of aileron. Coming to the aileron size, larger aileron increases the surface area and which enhancing the roll control effectiveness. The greater deflection provides more lift difference, which boosting the roll rate of the airplane. Next, the heavier wings may reduce aileron effectiveness, which imparting rolling performance, and the higher airspeed improves aileron power due to increased airflow over the surfaces. And the aileron placements near to the wingtip generally which leads greater control authority. The aileron difference deflection and differentiation. When aileron deflects, they can change the camber of the wing, increasing or decreasing lift on each side. The upward deflection aileron reducing lift, while the downward deflection aileron increases lift. This differential differentiation or the different path creating the rolling moment, which initiating a rolling in the direction of lower lift. Effective aileron deflection is essential for precise roll control and smooth flight maneuvering. Understanding the this relationship between deflection and lift differential is key mastering low roll dynamics. Aileron power and roll rate. Aileron power directly imparts a roll rate or speed at which the aircraft can rotate about longitudinal axis. Higher aileron power allows a quicker roll rate and enables faster maneuvering in flight during operation. Roll rate capabilities varying by aircraft types and are critical in high performance and aerobatic aircrafts. Excessive roll rate can reduce stability, so aileron power must be optimized for the aircraft mission. Roll rate specifications are integral to meeting both safety and performance, which required in the designing of aileron. Next, coming to the aileron power in high-speed aircraft and low-speed aircraft. At high speed, aileron power increases due to higher dynamic pressure over the control surface. In a lower speed aircraft, the aileron power decreases, which makes roll control for more challenging and less responsive. In higher speed aircraft, which effectiveness required careful deflection of controls to prevent excessive roll rate. Whereas in a lower speed aircraft, like takeoff and landing, may require large deflection for adequate roll response. So aileron power adaptations across speed ranges is essential for maintaining controls in a diverse flight condition. Next, coming to the comparative between or the importance of aileron power in the aircraft maneuverability. Higher or high aileron power enhance maneuverability, particularly in aerobatics and military aircraft or in the fighter aircraft. Maneuverability aircraft benefits from quicker roll response, which allowing for rapid directional changes, whereas aileron design in such aircraft minimizes power to achieve high roll rate while maintaining controls. For stable aircraft, moderate aileron power provides control without compromising stability. In optimizing aileron, power is essential to balance maneuverability with stability for each aircraft types. Coming to the adversea and aileron power, adversea is a yawing motion opposite to the direction of roll caused by aileron deflection. High aileron power can intensifying adversea due to lift difference across wing. Pilot counters dihedral or the adversea by applying coordinated rudder inputs with aileron deflection. Excessive adversea affects coordinate turn flight, making turn less effective and stable. Managing aileron power and adversea is crucial for smooth and coordinate flight. The importance of aileron power on structural load. High aileron power can impose significant loads on wing during aggressive roll movement or maneuver. Structural strength and wing flexibility are critical to safely handling high roll rate, and the excessive aileron deflection at high speed can lead to structural strain and possible deformation. Engineer consider these loads in design for balancing aileron power with structural integrity. Ensuring controlled deflection limits is necessary to avoid overloaded the wing structure. Coming to the conclusion, the optimizing or the designing of aileron to operate a power in an aircraft design. Aileron power is a virtual factor in roll control, directly impacting maneuvering and responsiveness. It must be carefully calibrated to meet the specific need of the each aircraft or airplane and types and its mission. Balancing aileron power with adversea control enhances coordinated and effective flight. Structural load consideration ensures aileron power does not compromise aircraft integrity. Throughout the understanding of aileron power aids in design stable, maneuverable, and safe aircraft operations. So, thank you. We'll see in the next class.